Assalamualaikum and hi students. We will continue our tutorial discussion with face-to-face question 5th hour. Right? Okay, so this is a question. When plaster of Paris is mixed with water, it combines with water to produce gypsum. Right? So this is the chemical formula for gypsum and this one is the chemical formula of plaster of Paris. The reaction is isothermic, which explains why a plaster cast on a broken leg warms as it hardens. And you can see here, given to you the standard enthalpy values for plaster of Paris, gypsum, and water liquid. Alright, the question is, calculate the enthalpy for the reaction in kilojoule. Alright, so given to you the chemical equation or the thermochemical equation whose the delta H is unknown. Alright, okay, so basically if given to you the values, alright, if given to you the values of standard enthalpy of compounds or elements and given to you the target equation, alright, we can use formula to solve this problem. So you instead of by using energy cycle or algebraic method, you may use the formula determining the enthalpy of reaction by using the standard enthalpy of formation. So you may refer to your lecture notes the the formula, right? Okay. All right. So this is the formula where if you have the standard enthalpies of standard enthalpy formation of compounds or elements, all right, okay, and you are going to determine the enthalpy of reaction, you may use this formula where the enthalpy of reaction or the standard enthalpy of reaction is sum of the standard enthalpy of all the products minus sum of standard enthalpies of all the reactants, and you have to refer to the thermochemical equations where which the delta H is unknown. Okay, jadi awak kena refer thermochemical equation yang diberikan ini yang mana delta H-nya tidak diketahui, yang mana kita nak kira. And to use this formula, you have to refer to the stoichiometrical coefficient. You can see here in the thermochemical equation, the plaster of Paris here is 1. The stoichiometrical coefficient is 1. Okay, this one is 3/2. And for the product, which is gypsum, here is 1. Okay, jadi nilai standard enthalpy of formation itu, kalau kita nak guna formula ini, kita kena darabkan dengan stoichiometrical coefficientnya. Okay, so basically this is the method how we solve the problems where the standard enthalpy of reaction is equals to the sum of enthalpy of formations of gypsum sebab produk kita ada satu sahaja, okay, minus the sum of standard enthalpy of plaster of Paris plus water liquid. Okay, untuk water liquid ni kena darab dengan 3/2. Yang lain ni darab dengan 1 mol. So calculate the enthalpy of reaction carefully, so you will get the final answer negative 7.5 kilojoule. Okay, bukan kilojoule per mol tetapi kilojoule sebab dah tak ada per mol dah. Okay, reaction ini kita tak tahu reaction apa. Adakah dia enthalpy of combustion? Dia bukan enthalpy of combustion, dia bukan enthalpy of neutralization, tapi dia adalah satu reaction. Jadi tidak perlu letakkan per mol di sini. Next, continue with question number 2. All right. You have the lattice energy of sodium chloride is negative 776 kilojoule per mole. And the enthalpy change when 1 mole of solid sodium chloride dissolved in water is positive 4 kilojoule per mole. If the enthalpy of hydration of sodium ion is negative 390 kilojoule per mole, calculate the enthalpy of hydration of chloride in the dissolution process of sodium chloride. So, we are going to solve a question which is related to dissolution process. Okay, ataupun dissolution process ni adalah satu proses where solid sodium chloride dissolve to form an infinite dilute solution. Alright, so the question asks you to calculate the enthalpy of hydration by using the energy cycle method. So you have to construct an energy cycle method. Jadi dalam kuliah saya dah terangkan dissolution process involve 2 steps. Okay, so firstly you have to write the thermochemical equation that shows the enthalpy of solution of sodium chloride. Jadi kalau you tengok pada ayat ini, actually dia dah beri satu definition. Kalau you baca betul-betul, if the enthalpy of, if, dia kata yang atas ni, the enthalpy change when 1 mole of solid sodium chloride dissolved in water is positive 4 kilojoule per mole. So this sentence actually refers to the enthalpy of solution, of sodium chloride. Dia tak sebut directly, tetapi dia sebut dalam bentuk definition. Okay, so basically this process, involve 1 mole of sodium chloride solid, dissolve in solvents such as water and form an infinite dilute solution, where the solid sodium chloride will form sodium ion aqueous and chloride ion aqueous. Alright, okay, so this involves enthalpy change, which is called enthalpy of solution. So when you are going to construct an energy cycle, you kena salin thermochemical equation yang terlibat, labelkan delta H on the arrow and put the values including the sign. So here is positive 4 kilojoule. Alright, tak payah per mole sebab memang kita faham ini adalah untuk per mole. Okay, dalam cycle ni tak payah letak per mole. Nak letak pun tak ada masalah. Actually it is okay. Tak ada masalah sebab soalan ini melibatkan 1 mole ion tu semua. Okay, now this process involves 2 stages ataupun 2 step. Where the first step, the solid sodium chloride must separate its gaseous ion. Dia mesti pisahkan dulu. Okay, partikel yang membentuk sodium chloride ni adalah gaseous ion. So dia mesti pisahkan dulu menjadi gaseous ion, sodium ion gas and chloride ion gas. And this involve enthalpy change, which is called lattice energy. Okay, dipanggil lattice energy. Tetapi you dah belajar lattice energy, there are 2 definitions. First adalah energy release when 1 mole of solid ionic compound is formed from its gaseous ion. And the second definition is energy required to completely separate 1 mole of solid sodium chloride ataupun solid ionic compound into its gaseous ion. Sekarang ni kita dalam proses nak memisahkan 1 mole sodium chloride solid ini kepada ion-ionnya. So, energy is required. Therefore, negative 776 kilojoule per mole kat sini, awak kena tukar dia menjadi positif 776. Kilojoule per mole sebab sekarang adalah proses solid sodium chloride nak separate, nak pisahkan. Maksudnya dia nak pisahkan particles dia tu menjadi sodium ion gas and chloride ion gas. Jadi tenaga diperlukan. So the lattice energy value is positive value here, not negative. Kalau negatif maksudnya dia nak form solid ionic compound daripada gaseous ion. Itu proses yang terbalik daripada lattice dissociation. Next, what happened? Each gaseous ion undergoes hydration. So sodium ion undergoes hydration. Dia akan involve energy yang dipanggil enthalpy of hydration of sodium ion. Kalau ikutkan kat sini nilainya adalah negatif 390 kilojoule per mole. Okay, and same goes to chloride gaseous ion. Dia akan undergoes hydration, where this process involve enthalpy change, enthalpy of hydration of chloride ion, which is this one is, saya tulis macam ni, of Cl minus. Kat sini pun saya boleh tulis of sodium ion, which is unknown. Tetapi in terms of definition, mengikut definition, enthalpy of hydration is energy release when 1 mole of gaseous ion is hydrated into is hydrated. Maksudnya bila 1 mole sodium gaseous ion ini surrounded by water molecules, kita panggil proses itu hydration. Jadi dia akan menyebabkan energy is released. And basically, kalau kita lihat di sini, enthalpy of solution, enthalpy of solution adalah sama dengan the sum of lattice energy plus enthalpy of hydration, of sodium ion, plus enthalpy of hydration of chloride ion. We are going to apply the Hess's law. Okay, and since we are going to determine the enthalpy of hydration of chlorine, okay, so you have to rearrange the formula and determine the enthalpy of hydration. Okay, oleh kerana dalam contoh yang saya buat ni, saya masukkan terus kilojoule per mol. Kebetulan memang semua ini, kalau you tengok semua, sodium chloride ke, sodium ion gas ke, sodium ion aqueous ke, ataupun chloride ion gas, chloride ion aqueous, semua melibatkan 1 mol. So jawapannya memang at the end adalah memang kalau saya masukkan kilojoule per mol pun jawapannya memang negatif 382 kilojoule per mol. So wajib negatif 382 kilojoule per mol sebab kita mengira enthalpy of hydration of chloride ion. Tengok definition, dia ada perkataan 1 mol kan. Tetapi kalau dia melibatkan ion-ion yang melibatkan 1/2 tu, dia lain sikit kat sini. Dari segi delta H tu mungkin you kena bahagi 2. Nanti saya bagi contoh lah kalau ada kesempatan. Okay, kalau tak ada, you kena buat past tense question. Right? Okay, so now we go to the next question. Alright, lattice energy for potassium fluoride. Okay, potassium fluoride. So this is the lattice energy is negative 821 kilojoule per mole. And its enthalpy of hydration is negative 819 kilojoule per mole. Okay, so nampak ya, dua-dua tu dia dah bagi dalam unit kilojoule per mole, menunjukkan amount ataupun delta H kat sini adalah merujuk kepada 1 mole of the solid ionic compound and 1 mole of gaseous ion. Okay, so the question is calculate the enthalpy of solution of potassium fluoride. So soalan ini tak suruh awak buat, dia tak sebut nak guna energy cycle ke algebraic. So tak kisah. Tapi sebenarnya kalau kita ada maklumat apa ni? Kita ada lattice energy, kita ada enthalpy of hydration, and kita ada enthalpy of solution. So paling senang sebenarnya kita gunakan energy cycle. Cuma pelajar kena tahu nak keluarkan equation. Sebab itu di hujung-hujung chapter 2 ini, kalau pelajar tak boleh menulis thermochemical equation, tak boleh nak keluarkan thermochemical equation, satu masalah yang sangat besar. Alright? Okay, so how to solve this problem? So we start with the enthalpy of solution. The thermochemical equation with unknown delta H of solution, kita tuliskan dalam bentuk equation, kita masukkan dalam cycle. So yang mana maklumat tu? Yang ini. Enthalpy of solution of potassium fluoride. So make sure you write the correct equation. So we have 1 mole of potassium fluoride solid, dissolved in solvents such as water. So it will form an infinite dilute solution. So what happened? Potassium ion K plus aqueous and fluoride ion aqueous will be produced. Okay, so this involves enthalpy change, which is called enthalpy of solution, and it is unknown. We are going to calculate the delta H ataupun enthalpy of solution. And this process, macam tadi kita dah bincang soalan number 2, involve 2 steps. Okay, first, 1 mole of potassium fluoride solid will completely, suppose dia akan completely separate kepada apa? Its gaseous ion. Potassium gaseous ion plus fluoride gaseous ion. So this process will require energy, which is called lattice energy. So lattice energy di sini adalah negative 821 kilojoule. So saya tak letakkan per mole pula kali ni. Okay, saya letakkan kilojoule saja. And given to you in the question, the enthalpy of hydration is negative 819 kilojoule per mole. So actually negative 819 kilojoule per mole itu adalah jumlah enthalpy of hydration of potassium ion plus enthalpy of hydration of fluoride ion. Dia dah jumlahkan siap-siap. So kita transfer saja ke dalam cycle. Alright, so dua ini adalah enthalpy of hydration. Okay. So berapa? Negative 819 kilojoule. Alright. And by using or applying Hess's law, where enthalpy of solution, okay, equals to sum of lattice energy or lattice dissociation plus enthalpy of hydration. So enthalpy of hydration ni hasil tambah 2 ni lah, negative 819. Now we are going to calculate the enthalpy of solution. So by applying the Hess's law, okay, tunjukkan dulu dia punya Hess's law ni. Show the substitution and write the final answer. Positif wajib tunjuk. Sepatutnya you akan dapat positif 2 kilojoule per mole. Okay, sebab sekarang kita bercakap tentang enthalpy of solution. Heat change when 1 mole of potassium fluoride is dissolved in solvent or water to form an infinite dilute solution. Alright, so saya dah bincangkan ke semua untuk soalan 5th hour face to face. Jadi nanti kita akan sambung dengan soalan 6th hour non face to face and face to face. Alright, okay, thank you.